Assalamu alaikum. Welcome to this MATLAB tutorial. Today I am going to teach you how to design automatic voltage regulator model of power system using artificial neural network in MATLAB Simulink software. Friends, the first requirement to apply artificial neural network as an intelligent controller is that we must have the conventional automatic voltage regulator model of the power system. For your convenience, I am considering this simple automatic voltage regulator model of the power system as shown here. On this topic, I have already made the video, namely how to design automatic voltage regulator model of thermal or hydro power plant using transfer functions in MATLAB Simulink software. Therefore, if you can watch this video and apply the ANN controller in this model, then this model can be used for your master degree research or one of the PhD research objectives. Now just look at the model. It may be observed that in this model we are using the PID controller. Double click on this PID controller block. You can see the parameters of the PID controller are 1, 0.25 and 0.28 for P, I and D respectively. Let's check the voltage graph using the PID controller at these values. Run the simulation. In the previous video, as mentioned few moments before, we discussed that its response was satisfactory, which was obtained after several attempts. However, if you notice the graph, it still contains large overshoot and very long settling time. Therefore, its response can be further improved by using the PID tuner block available in the MATLAB Simulink software. On this topic, I have already made a video, namely how to design PID controller in PID tuner using the MATLAB Simulink software. In that video, the parameters of P, I and D after the tuning were obtained as shown here. After changing the parameters of P, I and D with the tuned parameters, press OK. Now run the simulation again to see the tuned response. You can see now the voltage response has improved and has zero overshoot and smaller settling time than the previous graph. Now let's learn how we can replace this PID controller with artificial neural network based controller. As we know that ANN needs the input and output data of the PID controller for its successful training. This requires the shifting of PID controller input and output data from the Simulink model to the workspace. For this purpose, just go to Simulink library, then go to Sync. You can see here 2 workspace block is available. Take this block and bring it in the model. Connect this block here. Double click on this block. In the variable name, write input because this is the input to the PID controller. In the save format, click on array and press OK. Similarly, to get the data for the output, just copy this block and paste it here. Connect this block here. Double click on this block. In the variable name, write output and press OK. Now run the simulation in order to shift the data from the Simulink model to the workspace. Now come to command window. You can see in the workspace section we have input as well as output data. Double click on this input and output variables to see their values. Friends, it may be noticed that output column contains some value higher than 1. Therefore, to get the best results, we need to change these values. For this purpose, change these values in such a way that its higher value must be lower than or equal to 1 as shown here. Now close this window. As we have received this input and output data, now we can perform the artificial neural network training by using the MATLAB program or GUI tool. Just look at this MATLAB program which is used to perform the artificial neural network training. Friends, I have already made the videos on artificial neural network series to understand its basics with title How to Implement Artificial Neural Network in MATLAB Simulink. This ANN series consists of 4 parts. Therefore, it is my strong suggestion to watch those videos first for the better understanding of the artificial neural network training. Friends, don't be confused with this code. It is very easy. This program has the advantage that this code remains almost same for any type of problem. Therefore, for your convenience, I have shared the link in the description section. You may download this code from there and directly use it for your training. Now let's start the ANN training. To do this, just click on this Run button. It will automatically start the ANN training. Friends, you can see 10,000 iterations are successfully completed. Let's check what is the regression curve for these 10,000 iterations. For this purpose, just click on this regression. It will show the regression curve for the ANN training. It may be noted that regression is equal to 0.99972, which is very close to unity. As we know that the criteria for the successful ANN training is that regression must be equal to 1. Therefore, it means that our ANN training is successful. Now close these windows. Look at the workspace section again. You can see here net block is available, which is the trained artificial neural network. Now we have to save it. First, we have to save it in any folder for our reference so that whenever we need, we may use it. To save it, just right click on this variable, click on Save As to save it in any folder of your choice and with any name of your choice. Now we have to shift this trained ANN model from the workspace to the Simulink. For this purpose, we have the MATLAB command known as gensim. Therefore, write this command and press enter. You will see the MATLAB has shifted the trained ANN model from the workspace to the Simulink. Now take this trained ANN block from here and bring it in the Simulink model. Replace this PID controller block with this ANN controller block. Friends, at this stage our model is completed. Now we can run the simulation to check the performance of the ANN controller. Click on this button to run the simulation. You can see the artificial neural network based controller has successfully provided the desired output voltage. Friends, in this video I have discussed how to design automatic voltage regulator model of the power system using artificial neural network as an intelligent controller in the MATLAB Simulink software. This model can be used to complete your master degree or PhD research objectives. Furthermore, you can even write research paper from this model and you can publish it in any journal. By repeating the same strategy, the artificial neural network based controller can be implemented for any model related to any field in order to complete the master or PhD research. That's all for today's tutorial. If you like it, then don't forget to like my video, subscribe my channel and share this with all your friends so that they may also get benefit from this video. Thank you very much.